This we discussed the silicon control rectifier or thyristor, and you have seen that thyristor has a unique property of reverse blocking capability, and it has almost similar blocking capability in both the directions. So that is the unique feature of thyristor. But the problem is due to the reverse recovery, the switching frequency of thyristor is very low. And in recent times when we need very high speed device, in that sense the thyristor is becoming obsolete. So we'll start power MOSFET. I think all you know the full form of MOSFET, isn't it?
Yes, sir.
So only
Yes,
this power
yes,
term is added with this. So we can say metal oxide semiconductor
field effect.
Field effect transistor.
field effect transistor. Okay, so structure wise it is available in two structures. One is called the planar structure and it's called the vertical structure. Planar structure, vertical structure. Okay, now vertical structure is much popular because it offers a very small resistance compared to the other form. So first I will draw a vertical structure, then we'll go for the discussion of working principle. Let us draw a power MOSFET in its vertical structure. Okay, so this is the vertical structure of an N-channel MOSFET. You know that there are two types of MOSFET available, N-channel and P-channel. Okay, so it's the structure of N-channel MOSFET, and the connection which is given by this pink color is basically made up of metal contact, and this layer which is drawn by this hatched line is basically a layer of silicon dioxide, okay, or any metal oxide also you can use. So this layer is silicon dioxide. Okay. Now, how to bias this? Now the symbol which we use for this, let me draw that first, then I will go for this working principle. So this is the G terminal which is called gate. Can you tell me in which way arrow we should show here and where we should show the arrow?
Middle.
So middle layer.
Middle layer, and which way? Towards the gate or away from the gate?
Inward.
Hmm?
Sir, away.
Away from the gate.
Towards. No, towards.
Okay, so this is
Towards.
the N-channel MOSFET. This is D called the drain and A is called the source. Now, can you tell me in which direction the current is supposed to flow? Drain to source or source to drain?
Source to drain.
Source to
drain.
drain. No, the current is supposed to flow from drain to source.
Drain to self. Drain to source.
So drain to source, the current is supposed to flow. So accordingly, we have to provide the biasing. Okay, now how I can bias this? First, the main channel, if you want to see which is the main channel, the main channel, as I told you, that main channel is drain to source. So that is the main channel. And now that channel can be controlled by the voltage which is applied between gate to source. Okay, so that means first we have to provide the voltage between the drain to source. And these two A's are basically the same, is shorted because it's a circular one. So this is how it has a bias. This voltage is called the drain to source voltage, and this is the load resistance. Okay, and if we control this voltage, which is called the gate to source voltage, we can control the conduction through the drain to source. Okay, this current which is flowing into the drain is called the drain current. Here, now in on state, that also you can remember this particular device in on state behaves just like a resistance. It's a variable resistance. Hmm. In on state, it's just like a variable resistance between the drain to source. Okay, so that is the speciality of this MOSFET device. That means it is just like a ohmic resistance in the on state. So how it uh, operates, how what is the working principle? Then I will discuss that. So working principle. I think you also know a little bit because you have already gone through in your electronics classes. Okay. Suppose if I apply a positive voltage between the gate to source. With respect to source, a positive voltage is applied at the gate as given in the figure. Now what will happen? So it will induce as you have the insulation kind of layer in between. So you can expect a static charge will be developed in this region, isn't it? So there will be some static charge developed. So which polarity will be developed here if we apply positive here? So which polarity we can expect in this layer, other side of this insulating layer? Hmm?
Negative.
So negative.
Oh, so that means here we can expect some negative charge develop due to the electrostatic induction. Clear? Because silicon dioxide is basically an insulating layer. So other side of the insulating layer, we can expect a static charge will be developed, and that is with the negative polarity. Is it clear or not? Now, huh?
Sir, could you repeat? Sir, one connection was lost.
I'm not getting. Your voice is getting break. শুনতে পাচ্ছি না। ওকে, কিছু বলছিলে? Anybody has any doubt? I don't know. Okay, so if the negative charge is developed in the p layer portion, because already you have a p layer portion there. Okay, so if that is developed there, then what will happen? Then there is no junction basically. So that means the current can flow through a homogeneous substrate. That means all through the n substrate, the current can flow because everywhere you have the n substrate. Okay, slightly there was a p substrate, but due to this electrostatic induction, there also the channel becomes through. And how much it will open, that depends on the how much voltage you have given between source to gate, isn't it? Is it clear? Once there is a there is an electrostatic induction in this p layer, and this portion of the p layer becomes through, then all throughout the current can flow through this n channel only, because n plus, then this layer, then n minus, then n plus. That means all throughout you have the n substrate. So that means current can directly flow from drain to source through this n substrate. So there is no junction. Okay, so as there is no junction, that means in on state, it will behave just like a resistance, as if there is a substrate through which the current is flowing. Okay, and why we are writing this arrow? Why it is a variable resistance? Because how much current you will allow to flow, that you can control by the gate to source voltage. The amount of gate to source voltage, the magnitude of gate to source voltage, if we increase that, then you can increase the depth of penetration. Okay, that means more negative charge will be developed in the P layer. Is that clear? বুঝতে পেরেছো? So that means you can increase this layer. So initially, suppose this layer is only this much, and if we increase the voltage, so this layer will be increasing. So in this way, and more number of current will flow from drain to source. Okay, so this is how it can be considered as a variable resistance in its on state. Clear? Now, if we observe minutely, then you will find another bipolar junction transistor here. Can you see that? In within this MOSFET, there is another bipolar junction transistor. Can you visualize that? Can you tell me that where it exists? Suppose this is the
N plus P plus N minus N plus and another N plus P plus N minus N plus.
so one you just see. Which one? Where I should draw here?
So N plus
So suppose if we call it drain and source and gate, between which two terminal we should draw that transistor BJT?
drain and source.
Drain and source, correct? Now in the drain, which terminal of the transistor will be connected? So it's basically an NPN transistor. So that you can see from here. So let me mark it. So this is basically that NPN transistor. Okay, so this is the NPN transistor. So this N is connected with, so another one N is connected with drain, another N is connected with source. So that means if I draw it like this, so it will be the emitter, okay, and what will be this base terminal of this transistor? That is the P substrate, isn't it? Can you visualize this?
Sir, can you repeat, please?
Okay, so as I have shown by this highlighter, yellow highlighter, so we have two junctions present in this device. So one is this NP, another is PN. So that means NPN transistor exists in this device. Now this N is basically the collector, the drain in substrate is basically the collector of the bipolar junction transistor. And this N substrate is basically the emitter of the bipolar junction transistor. And gate is the P substrate. Sorry, the base of the transistor, because for transistor we call it base. The base of the transistor is the P substrate. Now, what is the problem here? Okay, now when the MOSFET conducts, whether this particular transistor will be on or it will behave differently, because it is connected in parallel with the MOSFET. But the base is floating, as you can see from this figure. Base is floating. But if you observe minutely, then you will see that basically here the emitter. So if this is the emitter portion and this is the base portion and this is the collector portion, the base and emitter is basically shorted by this metal connectors. Okay, so that means we can say that this base and emitter of the transistor is shorted. Isn't it? Have you understood this point?
Yes, sir.
বোঝা গেছে ছবিটা দেখে? From this figure it is evident that though there is a NPN transistor exist with a floating base, but as we have extended this metal contact to this P substrate, মানে ব্যাপারটা যদি এরকম হতো, suppose I can make this like this. হ্যাঁ স্যার বলুন, একটু ক্লাসে আছি। হ্যাঁ হ্যাঁ হ্যাঁ, ঠিক আছে। Okay, suppose we have a metal contact up to this. Okay, now basically the base is floating. Here the base is floating. Unlike the previous case, here only the metal contact is with the N substrate. Okay, so N means this emitter portion. Okay, so with that it is connected. Now here the base is floating. Now if somehow there is some noise from some external source, some spurious noise or spurious signal is coming, okay, then by any chance that base emitter current may flow and this NPN transistor may be switched on. Okay, so to avoid this problem, what we do, we extend this metal portion to short the P substrate as well. Okay, so by doing this we basically short the base and emitter of the NPN transistor. Now what does it become if we short it like this?
Diode.
It will be just a diode, because one PN junction you have shorted. So BJT means two PN junction. Okay, NP PN. Okay, now one PN you have made shorted, so you have left another PN. Okay, so this P and N already there, so that means we can write it equivalent to a diode. Which way I should I show the diode? You have to say in which way I should show the diode. Which side will be the cathode of the diode and which side will be the anode of the diode? You have to say from this configuration. Already I have shown the NPN substrate. Follow?
Sir, N will be up and P will be down.
No, the cathode and anode.
স্যার অ্যানোড তো সোর্স সাইডে হবে আর ক্যাথোডটা তো ড্রেন সাইড।
Okay, so that means this. Is it okay? Now it is okay. So this called body diode of MOSFET, or sometimes it is called the anti-parallel diode. So this is very important feature of our MOSFET. Okay. Have you understood how we are getting this diode? So we should get the transistor with a floating base. But what we have done, we have extended the metal contact to the P substrate, and we have made this N plus and P plus substrate short. By that, we are basically shorting the emitter and base junction of the NPN transistor. Now, if we don't short it, if the base remains floating, then what is the problem? What may be the problem? Suppose we don't extend this metal one. If we keep this base floating condition, then what may be the problem? বলো?
স্যার ওই নয়েজ সিগন্যালের জন্য ট্রানজিস্টরটা অন হয়ে যেতে পারে।
Correct. So if there is any spurious signal, then this transistor may be turned on. So to avoid this, we make this short. Anyway, now there is another disadvantage of body diode. So what is this disadvantage? So disadvantage is that if we apply a reverse voltage, okay, so due to this body diode, it can't block the reverse voltage like your thyristor. That is the main disadvantage of MOSFET. Due to its inherent body diode, it cannot block any reverse voltage. You have seen in thyristor or SCR or GTO, gate on of thyristor. So they can block any reverse voltage. But our MOSFET, due to its inherent body diode or anti-parallel diode, cannot block any reverse voltage. So therefore, here the reverse voltage blocking capability is only 20 to 30 volts. Okay. Clear? Now another advantage is there of this body diode. Sometimes if the circuit contains some inductance, and during switching, what happens? The inductance tries to maintain the current flowing. Then we need a freewheeling diode. So sometimes this body diode or anti-parallel diode act as a freewheeling diode. So then you don't need to arrange additional diode for this switch. Okay, so like if you use a thyristor or if you use a BJT, then you have to arrange additional diodes for freewheeling. Okay, but here, as the power MOSFET as a switch inherently contains some body diode, you don't have to arrange for any freewheeling diode. So that is the advantage of this body diode. Okay, clear. Now, how to make the MOSFET off?
কি বলেছো?
How to make this MOSFET off? কি করে অফ করবো বলো?
VGS 0.
Okay, so that means if we withdraw the gate to source voltage, if we remove the gate to source voltage, then the MOSFET will be just turned off immediately. Okay, so that means what we need, you need just a voltage. By that, it's very simple to make a power MOSFET turn on and off. And there, as there is no storage phenomena like the thyristor or BJT or diode, simple diode. So there you have seen that there is a storage phenomena. So due to the storage phenomena, inherent capacitance is there. Okay, so there due to that you have seen that reverse recovery phenomena in most of these devices. But here you don't have any storage problem, storage charge problem. Okay, so here only you are creating a channel. Only you are creating a channel by electrostatic induction. And you can withdraw this induction. You can remove this induction by withdrawing the gate voltage. So therefore, the switching frequency of power MOSFET is very, very high. Okay, the switching frequency you can make in the order of 500 kilohertz. Is clear? So that is the main advantage of power MOSFET. And the disadvantage, as I told you, that it doesn't have any reverse blocking capability. Do you have any doubt on whatever we have discussed today on power MOSFET? Okay, so
স্যার
then
ওই ডায়োডের স্যার অ্যান্টি প্যারালাল ডায়োডের স্যার ডাইরেকশনটা কি করে লোটে স্যার একবার মানে অ্যানোডটা
PN,
ক্যাথোডটা কোন দিকে লোটে স্যার রিপিট করলে বল
you see, this is short. Okay, now you have the P substrate and N substrate. So PN
Yes.
টা আমরা যখন ডায়োড ড্র করি, suppose this is a diode, so this is P and this is N. Okay, now
Yes.
which side we should show the cathode and which side we should show the anode? Like this only.
Yes.
So here you have see here this side is P substrate and this side is N substrate.
Yes, yes, understood.
Is it clear? Okay.
Yes.
Now, like all these devices, we'll discuss a few parameters, important parameters, which is required to select or to choose a proper power MOSFET during our application. Okay, and all these parameters are available in the data sheet of the power MOSFET, of any power MOSFET. Okay, so if we have a power MOSFET, specific power MOSFET, and if we type that name in Google, then you will get some data sheet for that power MOSFET, and in form of PDF file. And if you open the PDF file, then you will find out there are a set of parameters given. Okay, so among them I have listed a few which are the most important one. So first one is the RDS off. What is this? This is called the resistance between the drain to source. Resistance between drain and source when the MOSFET is off. Okay. So typical value is several megohm. Now the second parameter is the RDS on. Again the same thing, resistance between drain and source when the MOSFET is on. Okay. And it should be as low as possible. So another disadvantage of power MOSFET is that in on state there is a resistance called RDS on. Okay, and due to this resistance, finite resistance, it creates a very high loss, power loss, because you know if there is a ohmic resistance, then we can get a ohmic power loss. So due to this RDS on, there will be a huge power loss because of this ohmic power loss. Clear? So that value of this RDS on should be as low as possible to reduce the on-state power loss of power MOSFET. Clear? Number 3 is VDS. So this is called the permissible voltage between the drain and source. Permissible voltage between drain and source. Oh, okay. For biasing. It's stuck. Okay. Continuous drain current rating. So this is called the steady and continuous permissible drain current. then come to the maximum value of drain current. This is basically the instantaneous value. Instantaneous maximum permissible drain current. Okay, now which value we can expect more? ID max or ID continuous? Instantaneous value or
ID max.
continuous? So instantaneous value everywhere is more than the steady state value. Okay, so sixth one is the gate to source voltage, VGS. Voltage between gate and source, gate and source required to turn on the device. Device means the MOSFET. Okay, so these are the parameters, important parameters for power MOSFET. Okay. Now I will discuss important characteristics of power MOSFET. Most of the characteristics I have discussed. So the first one, which is very important, that the gate drive power required for this device is very low. Can you explain this point? Why the gate drive power is low for power MOSFET?
ইনপুট ইম্পিডেন্স হাই তাই জন্য
তাতে এটা বুঝলাম। কেন ইনপুট ইম্পিডেন্সটা হাই? Why the input impedance is high? Hmm? Let me ask Sheosh Khatri.
sir.
Can you explain this point?
Lower gate drive power is required.
Yeah.
Input impedance has sir probably off-state high resistance থাকতে হয়, that's why input impedance has to be high so that off-state current does not flow through it.
Which
আমি
one?
ঠিক জানি না স্যার, আমি জাস্ট আমি বলছি কি
বলো।
স্যার ইনপুট ইম্পিডেন্সটা হাই হতে হয়, প্রবলি বিকজ অফ স্টেট কারেন্ট পাস করা উচিত না, সো দ্যাটস ওয়াই মেবি হাই রেজিস্ট্যান্স থাকা উচিত না ওই সময় মেগা ওহম, দ্যাটস ওয়াই মেবি ইনপুট ইম্পিডেন্সটা হাই থাকে।
ইনপুট ইম্পিডেন্সটা হাই কেন হয়?
স্যার হয়তো সিলিকন ডাইঅক্সাইডটা রয়েছে তাই জন্য।
Correct. So you have an insulating material. So you have the insulating material between the semiconductor substrate and the metal contact, isn't it? So between that two, you have a insulating material. So if there is insulating material, hardly the current will flow through it. So if there is no current flow, so no question of power loss.
ওকে,
Okay, so that means
ঠিক আছে।
by its inherently it has a very high input impedance as it contains a silicon dioxide layer, which is insulation basically. So therefore there is no current flows through this and no question of power loss or very little power loss due to the leakage current. Okay. Another point is that inherent anti parallel diode. So another advantage of this lower gate drive power, which I have written in the first point, is that the control circuit which is required for this gate drive, the design of the control circuit is much simple. Control circuit is much simple. Okay. So inherent anti-parallel diode, which can also be used as a freewheeling diode. So that is the characteristics, or you can say advantage of power MOSFET. Okay, so number 3, it has higher on state voltage drop, because as it has a resistive nature in on state, ohmic nature in the on state, because the current flows through a homogeneous substrate. So therefore the on state voltage drop is quite high compared to the other devices. Okay, and as the voltage drop is high, there we can expect higher loss. Okay, the next point is, unlike the bipolar junction transistor, here we don't have any second breakdown phenomenon. Second breakdown like BJT. Okay, so these are the characteristics, and another very important feature is that
Sir, second breakdown
second
phenomena.
breakdown phenomena is a typical phenomena which occurs in case of bipolar junction transistor, and therefore it the second breakdown phenomena dictates the safe operating area. So in the safe operating area, I have shown different portion. Okay, so if you can remember, I have shown 4 portion. So one of the portion is due to the second breakdown phenomena. Okay, so the second
স্যার মানে
breakdown phenomena I didn't
এটা
discuss in
কিসের জন্য
details.
হয়
Huh?
এটা স্যার মানে
Actually,
কি জন্য হয় বিজেটিতে মসফেটে হয় না এখানে পাওয়ার মসফেট
মসফেটে হয় না, তার কারণ হচ্ছে মসফেটের যখন তোমার মানে অন স্টেটে যখন কারেন্টটা ফ্লো করে, দেয়ার ইজ নো জাংশন ইন দ্য পাথ অফ দ্য on state current, but in BJT there the junction exist. Okay, সেই জন্য ওখানে একটা সেকেন্ড ব্রেকডাউন ফেনোমেনা বলে ব্যাপার আছে, সেটা আমি ডিসকাস করিনি। ইনফ্যাক্ট there is it is not there in your syllabus, but
ওকে
you just try to remember that this second breakdown phenomena is a limitation of BJT, and this second breakdown phenomena dictates the safe operating area that I have discussed. The area within which you have to keep your operating point of a particular bipolar junction transistor that I discussed. Okay, so another very important characteristics of power MOSFET is that it is very easy for paralleling operation. Okay, so that I discussed at the very beginning, the first class, that for power electronic switches, sometimes we need to make multiple devices parallel, and to connect multiple devices in parallel, the important feature is that the thermal stabilization. Otherwise there can be a thermal runaway. Okay, and you have seen that in power MOSFET, in on state it behaves just like a resistance, and as the resistance has a positive temperature coefficient, so that means the power MOSFET gives a very good thermal stabilization due to its inherent on state resistance. Is that clear? Is that point clear? If you can remember, at
Yes,
the
sir.
very first class I discussed that. So if the device offers a negative resistance characteristics, that can result in a thermal runaway if you connect those devices parallel. But if the devices offers positive temperature coefficient, then it can result in a thermal stabilization. Okay, so let me write the point. So very easy parallel operation, okay, as it gives thermal stabilization due to its inherent on state, okay, so inherent positive temperature coefficient. Okay, is the point clear? How it offers a very easy paralleling
sir.
operation. Okay. Number 6, that also I have mentioned this point. There is no storage charge effect. Okay, so like any junction device. Now, what is the advantage due to this?
Switching frequency is very less, very
Bolo?
high.
Therefore,
Sir, switching
Sir,
frequency
টি
is
অফটা
very less.
কম হবে তো সুইচিং
therefore
ফ্রিকোয়েন্সি
that means
ফাস্ট
the
হয়ে যাবে।
switching frequency can be very high. Switching frequency can be very high. Okay. Now the switching frequency can be 200 kilohertz, can be 500 kilohertz, or can be 1 megahertz as well. You cannot, you do not get any device in power electronics or in electronics which can give you 1 megahertz switching frequency. There is a unique feature of power MOSFET. Okay, that clear? So these are the important characteristics of our MOSFET and the available ranges which you can get in market, like this, like this. So these are the available range of our MOSFET. So other MOSFETs are also available, but this is a typical range of MOSFET. Okay. Now, if we compare the bipolar junction transistor and power MOSFET, so what are the observation we can make? So if we are asked to write the comparison between two devices, one is BJT, another is MOSFET. Okay, both of the power BJT and power MOSFET. What are the observation we can make? So first is the on-state voltage drop. On-state voltage drop. What we can write for BJT about this on-state voltage drop? Hmm?
Low
On
on state.
Low as compared to MOSFET.
on-state voltage drop. So that is a low. So low on-state voltage drop, and therefore the steady state power loss is less. Steady state power loss is less. Now compared to this, it offers more on-state voltage drop, and therefore the steady state power loss is also more. Okay. Number two, another important characteristics of any device, that is the switching frequency. Now what we can write for it, BJT, about the switching frequency?
Lower.
So that means it also has very low switching frequency, as it has this junction problem, that is the storage charge effect. Okay. Is that clear? Here the switching frequency high. Okay. Now what we can conclude from this switching frequency?
T off is high
No,
in
no,
case of BJT.
that is the reason. I'm asking the effect. So as it offers low T off, therefore the switching frequency is high. Now I'm asking that what is the advantage of this high switching frequency?
Power
The
is
switching
less
losses will be
required.
less.
No,
Switching losses will
switching
be
loss
less.
no.
Less power is required.
স্যার
No.
হাই ফ্রিকোয়েন্সিতে সাইজ ছোট হয়ে যায়
Correct. That I already discussed in the second class. Okay, so that means the converter size. Okay, so the converter size
Yes,
will be less. Converter size and thereby the cost is less. Converter size and cost is more. Clear? So these 2 points are very important points related to BJT and power MOSFET. When you will select your device, then you have to think of these characteristics. Okay, now if we go for this availability, BJTs are available at high current and high voltage. Okay, so that you can say an advantage of BJT. But here, as I have seen the available range, available at low current and low voltage. So how you can avoid this problem? Do you have any suggestion? How can we avoid this problem? Or how we can tackle this problem during the implementation? Don't avoid, but how can we tackle this problem during implementation?
লো ভোল্টেজ এ করার জন্য সিরিজে অনেক কটাকে একসাথে কানেক্ট করে দেয়
Series or parallel
লো
connection
কারেন্টের
could be required.
প্যারালাল
So that also I think I have discussed in the initial classes, isn't it? So that is the disadvantage of power MOSFET, you can say. So number 4, more base drive power is required because it's a current control device, isn't it? So you need a base to emitter current to switch on the device, isn't it? But the power MOSFET is basically a voltage control device, and the conduction starts by electrostatic induction. So therefore the power requirement is very low. So low gate drive power is required. Okay, so this is the advantage of power MOSFET. Okay,
So please ওটা রিপিট করবেন লো গেট ড্রাইভ পাওয়ারটা কেন কম
একটু আগেই তো বললাম
গেট ড্রাইভ পাওয়ারটা কেন কম
একটু আগেই
এরকম
তো
কানেকশন
বললাম।
ছিল না স্যার, বেরিয়ে গেছিলেন।
Okay, because the power MOSFET offers very high input impedance because it has a silicon dioxide layer which is insulating material by nature. So that is placed between the metal contact of source and the other substrates. Okay. Now when the gate current flows, so that is very less because in between you have a insulating material. Is that clear?
Yes.
So
Yes, sir.
current যদি কম হয়, if the current is less, then the power which will be required to drive the gate, that is also will be less,
Yes.
isn't it? So therefore, low
Yes.
gate drive power is required for power MOSFET. And the fifth point, which also can be written here, that is the second breakdown. Again, the second breakdown phenomena is present here. No second breakdown phenomenon. So that means from this we can conclude that both the devices has their own advantage and disadvantages. Okay, isn't it? So both the devices have their own advantages and disadvantages. But if we can have a device which will include the advantages of both the devices, that will be very good, isn't it? Such a device is called IGBT. Such a device is called IGBT, or what is the full form? Insulated gate bipolar junction.
Bipolar junction.
Okay, insulated gate bipolar junction transistor. Okay, so that is called the IGBT, which includes the advantages of both BJT and this. Okay, and the symbol of IGBT is basically a transistor, but the base or gate is isolated. So this is the symbol of base emitter, and this is the gate. This is not base. For IGBT, this is called the gate. So this is the symbol of IGBT. Okay. Now I will discuss the IGBT in details in the next class, and there I will end the discussion on devices, and I will start the discussion on circuits from the next class. So next class, I will take the next class on Saturday. I think you don't have any class on Saturday in the evening, isn't it?
No, sir,
Ankit,
this time is fine.
do you have any problem?
Yes, sir.
No, sir, anytime after. Sir, after lab, anytime you can take class.
Yes, I. Oh,
After?
STC ma'am will take a class after that.
Okay, this Saturday
We have
actually
a
this
lab.
Saturday.
6 p.m. it's okay.
Bolo?
Sir, after 6 p.m. it's okay. Like today we had the class, we can have.
Okay. But this Saturday I have a. In the morning time, do you have any class?
No, sir, as of now we don't.
Hmm?
So no, sir, as of now, we don't have any.
in the morning,
Not
isn't it?
No,
So
sir. As such.
if I take at least 1 hour class, if I take from actually, I have a meeting on Saturday from 4 to 5:30, then 6 to 7:30, and before that I have a class from 1:45 to 3:15. So already I have 3 scheduled meeting. So I'm thinking that where I will keep your slot. Okay, I think morning will be better for me. ঠিক আছে আপাতত 11:30 ধরে রাখি in the morning. You don't give that slot to anybody. Let us see. I will take your attendance. Just a minute. Just wait. Take your attendance. Zero two. I'm just calling your names. Don't respond. If somebody miss, then you point out. 02, 06, 09, 10, 10, then 17, 18, 19, 20, 22, 29, 30, 32, 34, 37. Next, 38, 44, 53, 54, 58, 59, 60, 66, 67, 69. Next, 70, 74, 77, then lateral 2, lateral 5, lateral 6, lateral 9, lateral 10. Okay, so lateral 10, lateral 12, lateral 13, and lateral 14.
Sir, 0 sir, lateral.
0,
04 sir, 1004 lateral.
oh,
Sir,
4, okay, 4 is
lateral
also,
15.
where is lateral 15? Okay, I'm giving that.
The lateral 3.
3টা তো আমি দিয়েছি। Okay, anybody else who has left? Anyway, so thank you very much for attending this class.
Thank you.
Thank you.
I'm stopping
you,
this
sir.
share. I'm stopping this